Alright, so as it stands, I'm looking at this equation right here. Not yet sure what it looks like. I've got a hunch that it's going to be facing downwards, this parabola, because of that -1, my coefficient on the x squared term. But we need to do some work in order to put this in a nice vertex form of our parabola so that we know what its vertex is and we can graph it really easily. I already know, to be quite frank, I already know from that -1 coefficient. I know this right here is going to be a -1, so we've already got a head start. But we got to do some completing of the square anyway. And so, of course, I see this coefficient on my x squared. It's not a 1. I don't know how to complete a square without a coefficient of 1 on our x squared, so I'm going to go ahead and factor out a -1. And I'm going to factor it out of just the first two terms in this case. And I'm going to leave this -9. I'm just going to let it be. I'm going to let it be. I'm going to hang out there on the side. So now I see, well, I've got 2/3 of a perfect square trinomial. I definitely need to complete that square to put this in vertex form. So we know what we need to add. We need to add a 16. So add a 16 there. We still got this -9 from before. Nothing special happening there. And so we're now going to figure out what we need to do to keep this equation balanced. Well, if I were to distribute this -1 through, I think we would have a y equals -x squared. That's exactly the same as our original. I think we'd have a -8x. Okay, that's exactly the same as our original. I'm going to keep this -9 hanging around. That's exactly the same as our original. So far, our original is exactly the same as it was. We haven't done anything to the equation, but of course, when I multiply this, I get a -16. And so, in order to have this whole quantity be equivalent to this original equation, so that we haven't actually changed the equation, I need to add a 16 as well. And so this tells us, oh, okay, that's what I needed to add in this step right here in order to keep the equation balanced. Okay, so I'm going to add a 16 right there. Okay, so now we're ready to go. We're ready to actually put this in vertex form. Well, here's the deal. Here we've got our perfect square trinomial. Y equals -x plus 4 quantity squared. And these add to, what, 7? Plus 7. So we've got it in vertex form. Indeed, just as we thought before, this coefficient happens to be a -1. We knew that from up here. And so we say, well, our vertex in this case is going to be the point -4, 7. I think our axis of symmetry will be the vertical line x equals -4. I would always urge you to go ahead and draw not only your vertex, well, of course you're going to draw your vertex, but your axis of symmetry. I find having that dotted line that tells me how my parabola is going to be symmetric, I find that really helpful. I often also, the next thing I always do, I just find my y-intercept. Boom. There it is. Our y-intercept. And that's just going to give me at least another free point with which to help sketch our parabola. Alright, so our y-intercept is -9 in this case. So way down here. And I know if I've got a point 4 units to the right of my axis of symmetry, I definitely need one 4 units to the left as well. And so I'm going to draw another point 4 units to the left. 1, 2, 3, 4 units. Alright, so we got a pretty good idea of what this guy's going to look like. I'm always interested in knowing the X-intercepts. That's a really important thing for us. So let's go ahead and find them. I'm going to do this in hot pink. And we're going to use this equation right here. I'm just going to set my y-coordinate equal to 0, and we'll solve for what x values make that statement true. Alright, here we go. So let's subtract 7 from both sides. So -7 equals -x plus 4 quantity squared. I'm going to multiply both sides of this equation by -1. 7 equals x plus 4 quantity squared. Take the square root of both of these guys. Plus or minus the square root of 7 is equal to x plus 4. And so it appears that our x-intercepts will be -4 plus the square root of 7 and -4 minus the square root of 7. Now, these are not super nice numbers because we got this irrational square root of 7 business. But, you know, 7 is between 4 and 9, so I'm guessing its square root is going to be between 2 and 3. So our x-intercepts are going to be between 2 and 3 units away from -4, which also happens to be our axis of symmetry. So between 2 and 3 units away. So 1, 2, and change. 1, 2, and change. And so we are looking real good. I mean, we've got a whole lot of points here. I feel pretty confident going ahead and sketching our parabola right away. And so, not perfect, but doing my best. I'll try that one again. That was a lot better. And there's our parabola right there. Note to self that if we had tried to find the y-intercepts by plugging in the x-intercepts by setting y equal to 0 in this equation, totally would have worked out fine, but as you can imagine, this does not factor nicely. What would we had to do? We would have had to complete the square, which we already did when we put it into vertex form. So my suggestion when finding x-intercepts is just use the vertex form. It's going to be a lot easier if you have irrational x-intercepts, and if you have nice intercepts like 1 or 5 or 2 or -3, it's going to be fine either way.